chain rule, product, and quotient rule review. So first thing you should notice is that I did put the product and quotient rule here from the IB formula sheet, so you could use right there. Keep in mind, right, this just means derivative. So we have uv. I'm taking derivative of that guy. You get this, that this guy dv is just v prime, and du is just u prime. Same thing down here. So that's how you should see them, and that's all they are. So let's go to this first one. Now this first one's actually a chain rule, right? Notice there's only one variable. It's inside another thing, so it's a chain rule. We're going to take a derivative of the outside. So we're going to bring that down, subtract one off, leave the inside alone, and then times by the derivative of the inside. So the derivative of the outside, bring that down, subtract one off. It's 2 over 2. So I get 1/2, negative 1/2, because 1/2 minus 1 is negative 1/2. I'm going to leave the inside alone. So that's 4t plus 9. Right, since I left that alone, I got times by the derivative of that thing. So times by 4. Then I can simplify this. This is y prime, by the way. And I can multiply the outside terms, because they're both numbers, and I get 2, 4t plus 9 to negative 1/2. And that's my answer. Next one. Now this one has two separate x's, so this is the product rule. This is like my u and my v. And all it is take derivative of one of them, leave the other one alone, then switch it. Take derivative of this one, leave that one alone. So derivative of e, f prime here, is just e dx. Leave the other guy alone. Plus the derivative of this guy, the derivative of that guy would be 3x squared, and then the minus 1 goes away, because it's a constant. Then times the first one left alone, so times e to the x. And there you go. Next one, e. That's another chain rule. Right, so this x squared is inside the e. So take derivative of the outside. Now, e's are a little weird. I actually think of e as kind of a separate problem. If I see e to the u, the derivative of that is this e to the u times u prime. Almost like its own special rule, because the derivative of e is e. So the derivative of the outside is just itself. And then leave the inside alone. Then times by derivative of the inside. Derivative of x squared is 2x. So I get that. But people always kind of freak out when they say an e. It's just, I always think copy it and times by derivative of the power. Always. That's how you do e. Just copy it, times by derivative of the power. The next one, that is a series dividing, so that's a quotient rule. So this is my u, this is my v. The quotient rule is all like the product rule, but there's a minus on top. The key things to keep in mind, take derivative of the top first. So it's the derivative of the top first. If not, just use the formula. So the derivative of the top is 1 times the bottom left alone, minus the derivative of the bottom, which is 1 times the top left alone, all over the bottom squared. Like that, and I can simplify the top a little bit. And I would get, this is f prime would equal x minus 2 minus x, or x minus 2 squared. These cancel. So I get f prime equals negative 2 over x minus 2 squared. Like that. Moving on. This one is a product rule I could do. You could also simplify it out, multiply it out, and then just do a normal. That's what I'm going to do first. Let's do that first. Let's distribute it out. So I get t cubed plus 9t squared plus t plus 9. Now, again, in this case, I haven't taken a derivative, so that's just what it is. And now I can take a derivative. So 3t squared, I don't know why I put 3tt, plus 18t plus 1. Right? The coefficient here is 1, so go 1. That's a constant, so it goes away. So that'll be my answer. You could also do it by product rule if you want. So I'll do that right here, I guess. The first one is 2t. The second one left alone. Plus the derivative of the second one, which is just 1, times the first one left alone. Then if you want to see it be exactly the same, you add like terms. Plus t squared. Plus 18t. Mess that up. Plus t squared plus 1. Add like terms. And I get that guy. Right? 2t squared plus t would be 3t squared, 18t, and then 1. So either way it gives you the right answer. So either way you prefer. show our product rule, or you go, hey, I know I can simplify that. The next one, these are both chain rules. So if I take it, remember what we do ease. You just want to copy them, then times by derivative of the power. So derivative of negative x will be negative 1 plus, again, the way you do ease, copy them, and times by derivative of the power, so negative 2. Simplify that a little bit, negative 4e to negative x plus, I guess, minus 14e to the negative 2x. Little movie magic, if you saw. I had to change. I just realized we haven't learned how to do the derivative cosine, so I had to change it mid spot. Your worksheet should have this down on it already because I'm just going to change my worksheet. But yeah, I can do one beforehand. So I did this one instead. This will look a little more fun. So first, product rule or quotient rule. Well, there's two separate x's, so that's a product rule, right? That's the general rule. Like here, there's two separate t's, so product rule. There's two separate e's, but they're connected by the plus sign. So this is just one, like, this is like its own term. These are two separate terms. One term, two things, that's why it's a quotient rule. The hardest one for most people is quotient rule, product rule and chain rule. So I always think about, like, are they connected? These two are not connected. So that makes it a product rule. Now the thing is, inside that product rule, the derivative of this would be a chain rule. And look over here, inside that product rule, inside the product, this is part of the product rule, that is a chain rule. So we have both here. We have product rule and chain rule. So to make it a little easier to see, because it's a little different, I'm going to do this. Right? I'm going to write the formula right here. U prime v plus v prime u. Remember, it doesn't matter which one goes first for adding. It matters in quotient rule, but it does not matter in product rule. And for me, that's the quotient rule way. I like it that way. Okay, so take the root of the first one. So here's e. Remember the way we do e's? Copy and times by derivative of the power. So u prime would be e to 3x times 3. Then we gotta leave v alone. This is v, so let's leave it alone. X squared plus 1 squared. So that's this side. Now we have a plus sign. Now we gotta switch it to get rid of the v. Now look at v here. That's a chain rule. Right? There's an x, there's a squared here. So you gotta take the derivative of the outside, the 2, bring it down, subtract 1 off. Leave the inside alone. And part ever forgets, multiply by derivative of the inside. So this should be 2x. And then people also forget, they do all that work and they also forget, don't forget the first part. Multiply by the first one left alone. So I can multiply by e to 3x left alone. And that would be the answer. I could spruce it up a bit, I can make it a little bit nicer. This side just rearranged a bit. Over here I could multiply the 2 and the 2x, it's going to be 4x e to 3x x squared plus 1. So I can make it a little prettier, but that's just the answer. Now the next one, this one's a straight out just chain rule. Notice there's multiple x's, but they're all connected together. So this is just a chain rule. Because you can see that this is inside the power of 2/3. So this is a chain rule. Bring the power down, subtract 1 off. So 2/3, leave the inside alone. Subtract 1 off, make a common denominator. So negative 1/3. Now again, I gotta leave the inside alone. So x4 minus x3 minus 1. And then don't forget the last part, multiply by the derivative of the inside. So the derivative of the inside is 4x cubed minus 3x squared. And that would be the answer. Let's move on. Oh, so this one, I love this one. So I give you a table here, and you have to answer these questions. Now, so look at the first one. I want you to take a derivative of f and g, f plus g, and then I want you to sub in 4. And then to get those values, you just need a table. Well, what's the derivative of f? Remember, don't overthink it. It's just f prime. And the derivative of g would just be g prime. Right? We're not doing a product, we're not doing a quotient, just f prime, g prime. And then sub in 4. So we'll sub in 4. Really, we're just going to look at the tables here, right? What's f prime of 4? F prime of 4 is negative 3. And then what's g prime of 4? G prime of 4 is negative 1. So I get negative 4. That's my answer. Okay. Right here. Now this one's a little different. It's f of x times g of x. So that's the product rule. So you gotta remember how to do the product rule. that would be the derivative of the first one. So derivative of f is just f prime times the second one left alone. So we're going to leave g of x alone. Plus the derivative of the second one, which is g, so g prime times the first one left alone. Like that. Right now, again, we're plugging forward into all these. So just look at the table here. So what's f prime of 4? Negative 3. G of 4 by itself would be 5. Plus g prime of 4, negative 1. And f of 4, which is 2. So negative 15 plus negative 2 equals negative 17. Like that. This one wants to take the derivative. Again, I mean, that's what we've been doing. But look at it, so you're dividing, so it's a quotient rule. So again, you got to use the quotient rule here. So the quotient rule, and actually I'm going to change this one up also to make it a little more fun. So you can see this live. On your worksheet, it'll be the way it looks. Not what I wanted. But I want to change this right now. Let's make this x squared. So this will make it a little different. Okay, so let's do this problem. So I'll take a derivative of x squared over gx, and then I want to sub in 4. So this is a quotient rule. We're dividing. So remember the quotient rule? It's the derivative of the top. So this is u and v. It's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Again, if you're not sure, it's on the formula sheet, and I made a version of it on top. So let's just do it here, right? So the derivative of the top, the derivative of x squared is 2x times the bottom left alone. That would be gx minus the derivative of the bottom. The derivative of the bottom would just be g prime of x times the top left alone, x squared, all over the bottom squared. So g of x squared. What's next? Now we got sub in 4 for everything, right? So even here, that's an x. We're going to plug in 4 there. So let me do it with colors. So we're going to plug a 4 in here. How about g of 4? Well, g of 4 is 5, according to the table. Then over here, we got g prime of 4. G prime of 4 is negative 1. Now remember, we're plugging 4 in for x. So this becomes 4 squared, which is 16. Then down here, we have g of 4 squared. Well, g of 4 is 5, so it's just going to be 5 squared. So if I simplify it a little bit, I get 20 plus 16 over 25, which is 36 over 25. So that's the answer. That's the answer to this one. Right, I changed it a little bit. You'll see like that on your key, on your worksheet. Okay, last one. Following diagram shows parts of the graph f where f of x equals x squared minus x minus 2. So this is a little bit of a function review. So here's our quadratic. They want us to find both x-intercepts and find the x-coordinate of the vertex. So remember, x-intercepts, the easiest way to do that is just, that's where y equals 0. So I get, or y equals 0, which in this case is just f of x. So we're going to set this equal to 0. And then we factor. This one shouldn't be too bad. It's just two things that multiply get negative 2, but add to get negative 1. Negative 2 only has 2 factors, so negative 1 and 2, and negative 2 and 1. And that would be the 1. Split and solve. X minus 2 equals 0. X plus 1 equals 0. So x equals 2, and x equals negative 1. Like that. So there's my x-intercepts, 2 and negative 1. So this one will be 2, this will be negative 1. Now they want you to find the x-coordinate of the vertex. Now there's two ways to do this. In your formula sheet, I don't have it here, but the vertex is negative b over 2a. So back to here, my a, right, it's always, this is like ax squared plus bx plus c. So if I was going to do it this way, it would be negative, my b would be negative 1, right, based on this. And then 2 times my a would just be 1. So to get 1 over 2, or x equals 1/2. X-coordinate of the vertex. Now that's one way to do it. The other way to do it, well, the vertex is always halfway between the x-intercepts. So you have negative 1 and you have 2. Add them up, divide by 2. So 2 ways to do it. So keep that in mind. That's an easy way to do it. If you have the x-intercepts, the axis symmetry, the x-coordinate of the vertex is only halfway between the x-intercepts. Anyway, that's the worksheet.